Hello, everyone. Kia ora from New Zealand. We want to welcome you all to this webinar. Welcome you to the second edition of the Yes, HIWeather webinar series. This webinar draws inspiration from the High Impact Weather Project, research initiative by the World Meteorological Organization and the World Weather Research Program. And this aims to achieve dramatic improvements in effective weather-related hazard warnings. This webinar series, The Power of Participation, Citizen Engagement in Weather and Climate Science and Action, will explore the role of citizen science in improving weather-related hazard warnings, increasing public awareness and understanding of weather science. So far in the series, we have a diverse range of speakers already from different parts of the world, discussing how to engage citizens in science projects that can improve forecasts for different timescales, enhance their communication, and facilitate social and environmental applications. We hope that by attending these webinars, you will gain deeper understanding of how citizen science can potentially be used to mitigate the impacts of extreme weather events. Today, we are very fortunate and we are very happy to welcome Dr. Thomas Krennert from GeoSphere Austria. And the title of his talk is The Significance of Human Weather and Impact Reports from a National and International Perspective. Well, Thomas Krennert has been a dedicated member of the Austrian National Weather Service, GeoSphere Austria, since 2000. Initially a satellite meteorology researcher, he now serves mainly as a senior forecaster. Alongside his operational responsibilities, Thomas conducts research on atmospheric convection and weather type classification while managing GeoSphere Austria's citizen science program. He is also the inventor and co-founder of the Trusted Spotter Network Austria, or TSN. So we welcome Thomas, and then we encourage everyone in this webinar to ask questions during the presentation. After Thomas's presentation, we will field your question and have a good Q&A session. So I'll hand it over to Thomas to share his slides.
Well, Marion, thank you very much for the nice introduction, and thank you very much for the opportunity to present and to introduce our program in front of such a highly expertise group of audience. So I go right into it. I want to introduce myself a little bit. What is my working environment? Where do I come from? What do I do? So just for the information, some of you might have had contact with the Austrian Weather Service, the Austrian National Weather Service, up to 2022. Our name was Zentralanstalt für Meteorologie und Geodynamik ZAMG. So since this year, in order to clarify some aspects here, we merged with the Geological Federal Agency, and now we are together. We are a federal agency for geology, geophysics, climatology, and meteorology. That's the first important point not to come to some differences in understanding what the GeoSphere Austria is actually. So you can see my working place in the northwest of Vienna, Austria, in the center of Europe, and I'm responsible for forecasts, for impact-based warnings, and for the citizen science program Wettermelden, which means reporting the weather. But I also am responsible for the so-called Trusted Spotter Network, which is in the framework of a citizen science program, is actually a training program for voluntary weather observers. So we change to a very, very common and very well-known schematic here. How do we define weather-related disasters? This is very well known to you, but I just wanted to add some local flavor. Austria is a very small country. Austria is a very mountainous country with a lot of orography. So let's take one example, for instance, a cloudburst with more than 40 liters per hour on the square meter. This will have a huge impact independent if it's on an urban area or a rural area. So how do we combine those variables of hazard, vulnerability, and exposure? The vulnerability will be an issue regarding, for instance, soil condition. Sealing is a very strong issue here in this country because of the high population density and of the high density of sealed surfaces on the ground, and the soil moisture coming to climate change, climate extremes, phases without any precipitation will harden the soil, and the moisture will decrease, and thus will not absorb any form of precipitation or hardly absorb any form of precipitation. And the complexity of our environment, of our living space, the anthropospheric, so it's called, is very exposed and vulnerable to floodings, but also a very high densely populated area as we are. We have a high number of regulations, for instance, building regulations, where to build, how to build. And we have different levels of bureaucracy which are regulating all these things. So there is the communes, then there is the counties, then there is the federal provinces, then there is the nation, and above all, there is the European Union. So we have to cope with different layers of bureaucracy, which makes the mitigation and the resilience against fast changing hazard risks very, very, very hard. So in this case, I want to take your awareness also to the bureaucratic aspect of how we are exposing ourselves to weather hazards and to fast changing conditions of these weather hazards. And of course, in Austria, even though it's a very small country, we have in between a very small scale, we have different kinds of areas, flatlands and mountainous regions, which will affect the catchments of rivers, which is also dependent on the variable of the hazard. The more rain comes, the higher the impact in the catchment is if it's mountainous in comparison to flatlands, for instance. So this is the local flavor of these hazard, vulnerability and exposure disaster risk matrix, which I want you to be aware of for the further information I will give you. And you also know these 3 guidelines from 2015 from the WMO, threshold-based warnings, which we did up to 2020. And we tried from 2021 as a National Weather Service, we tried to disseminate impact-based warnings. And for special collaborators, for special partners and customers, we do also, or try to do literally impact warnings for special occasions, for instance. So the impact warnings we disseminate are published in the internet on our homepage. We have a special domain here, which you can access and where you can gain all the information from us, from the warning forecasters. And we do this not automatically, but we do it individually by hand, and we have daily briefings where we decide which area in which intensity is affected by impacts of different meteorological parameters, as you can see in the upper right corner of the image. But we are also engaged with Meteor in the HIWeather framework. What does that mean? In Europe, the HIWeather framework gives the opportunity. This is an organization of national weather services of whole Europe, where we try to standardize and try to coordinate all the impact-based warnings we are giving in each country. So in Meteor Alarm, there is a homepage, meteoralarm.org, where we try to summarize all the impact warnings currently active in the whole of Europe. So the GeoSphere is also engaged in this project very prominently. I want to go to a very important issue here. This is a very complicated chart, so let me try to walk you through this. We start at the upper level corner. How do we issue our warnings? What are the sources of our knowledge and expertise to be able to issue a warning to the general public or to other stakeholders? We, as every other weather service, use, of course, weather station data. We use numerical weather prediction models, but also we use remote sensing data in a different time scale. So for the forecasting, for the mid-range forecasting, numerical weather prediction models will be of greater value. But if we come closer, temporarily closer to the event, so nowcasting techniques will be more important, supported by measurements of local weather stations and remote sensing data. But even a very high network of automated weather stations, we have about 280 in our country, with an average distance of 20 kilometers, which is a very, very dense network of weather stations. We have limitations, we have caveats. We cannot measure mudslides, we cannot measure hail sizes, we cannot measure wind damages with all those stations. So we need, for an outlook for impact-based weather warnings in real time, and also as in 1 or 2 days in advance. When we go to the upper right corner, in our office, we need alternative data and additional data. So we can issue the warnings to our stakeholders, which you can see in the lower right corner here. So in principle, we communicate with National Crisis and Disaster Management. There is a special organization here in Austria. This is the SKKM. And of course, the civil protection agencies and the most important communication partner in a crisis situation, in a weather crisis situation, are the federal alarm centers. We have 9 federal provinces here in Austria, and these federal alarm centers are coordinating disaster relief and other organizations. So the general public will be informed, and of course our partners will be informed, but also we are in contact with the European level, with the European National Meteorological Services via HIWeather program, but also with the European Commission via the European Research Coordination Center, the ERCC. And here we have also regular briefings many times during a week. And if you go to the lower part of the schematic, you can see firefighters in action. So this is a small alpine town, and you can imagine that, for instance, for very intense precipitation, mudslides are the most common impact and most common danger in this alpine area, when the precipitation causes a lot of mudslides and a lot of flooding in the river basins. So this is the most common impact with high precipitation. And I want to say to you that these firefighters are mostly voluntary firefighters, so they have to be alerted, they have to be summoned, and then they have to be sent to the center of the crisis, to the localization of the highest impact, in order to help the civil and the public in order to mitigate the crisis. So this is how it is organized in Austria, mainly organized. Only urban areas will have professional firefighter units. And the response is already here to the disaster and to the weather impact. But how do we gain this additional information about the ground truth? We as forecasters really want to know what's going on out there, so we can have better briefings, better warnings, especially to the federal alarm centers, as I told you already. So there is the possibility, everyone is using it, social media. So social media might be kind of real time, but is it reliable? Not really. We can use news outlets. So these are more or less not really real time. They are probably more reliable than social media. And there are a lot of other different sources, for instance, car data, crowdsourced car data, and so on, which we can use as a National Weather Service in order to get additional information about the ground truth in addition to our weather stations. But there is another aspect, namely the human weather and impact reports. So we are, since more than 10 years, we are utilizing the community of weather enthusiasts, meaning they are interested in the weather, either with us or without us. But still, as the National Weather Service, we can utilize the enthusiasm of those weather interested people. They are probably organized in spotter organizations and the like. So how do we utilize these reports? We provide a web app, not a native app. So you see, if you join the browser and what you see is a map, and if you decide to report any weather, we have 195 parameters which are already explained by their impact, which you can see below as a subtitle below these main categories which you can choose. And then you're going through a decision tree here. Already the impacts are explained already, and then you can disseminate your weather report. So this is very low entrance level and very low resistance entrance for using this web app, and it should be used by everyone. So everyone is able to use this app either with some training or without some training. So we also provide outreach platform where we, for instance, organize our workshops and where we organize our training sessions for the trained observers. There is another complicated scheme here. I want to take your attention to the center of the scheme, where the Austrian Weather and Impacts Reports database is located. This database is on the sub-national level, which is here below the center, connected through a standardized reporting parameter application programming interface. And in this regard, I want to tell you about a very important co-author, Rainer Kaltenberger, who is also responsible for this scheme and for this architecture, and also our programmer Thomas Spitaler did a lot of input, technological and technical input to realize our system here. So in every direction, our database is connected to other levels of collaboration through this standardized reporting parameter API. So on the subnational level, we have our partners, for instance, the Trusted Spotter Network, chaser organizations, ham radio operators, but also on the European level, we have connections to the HIWeather organization with other weather services, and of course to the European Severe Storms Laboratory, the ESSL, for instance, with their European severe weather database. I want to stress more the left side, the training. There are three reliability levels, three competence levels of observers without any training, online training or basic training, or the Trusted Spotter training, which is the most advanced training level we can offer. And of course, we manage our users, and as I told you already, we try to have a landing zone, so to say, for every interested person in our outreach platform. So how is the training organized? You see the training activities on the left side. In the center, you see reliability levels. The first reliability level is a first step of certification, and the reports are not anymore anonymous here. So we know on this level, we know the weather observers, which give us the information about the ground truth. And especially on the second level, certified advanced trained spotters, the trusted spotters, they are certified in this level, so they know about our activities, especially with the federal response units, agencies, and so on. So they are very well informed about the bureaucratic mechanics in the background if we deal with a weather crisis. And you see our training activities. This is upper left corner, individual training. And we provide multiple workshops during the year. And then you see also a formal form of certification, which every trusted spotter will receive. We also engage in KI image recognition, where we are going to follow the GDPR data protection laws in order to avoid identification of persons or license numbers of cars, which are selected automatically out of the published images, for instance. And we also are recognized as best practice for communication and outreach with our Trusted Spotter Network by the European Meteorological Society. We are going now to the European level. As I told you already, we are engaged in the HIWeather organization. There is a working group of crowdsourcing, and I have the honor of chairing the subgroup of app data, which deals especially internationally with human-based observers and human-based observations, which are mostly done via apps with all the other weather services. There are very successful apps established in Europe already, up to 150,000 reports every day, or on intense days with, for instance, thunderstorms could be expected, for instance, in France, in Germany, and also already in Belgium, more than 50,000 reports during a day. So these apps are really successful. The data from Austria will be on a very intense day. There are about 700 reports, up to 700 reports. And usually we deal with 100 to 150 reports, and especially from densely populated areas. So what are we going to do in the EuroMidNet framework? We try to standardize the reporting parameters, which we want to exchange also on a real-time basis with other European countries. The data transfer should be standardized. Quality management, of course, should be standardized among European national weather services. The observer training. So we are, I want to regard now to a survey from Rainer Kaltenberger from 2020, who did a survey with European weather services, national weather services, And of course, the majority of all forecasters really want to know what happens outside right now. They want to know the ground truth. So what we are doing and the standardization of these reports is very important and is obligatory for any weather service who is involved with impact-based warning activities. And of course, there are other scientific applications. I want to inform you, we did not invent this scheme. We just took it over. So in 2002, the European Storms Laboratory, which is a partner in our activities, they invented and established in 2002 the European Severe Weather Database with certain very strict categories and thresholds of reporting an impact, but they also invented here these quality checks, and the quality checks, they are equivalent in their levels, in their different levels, also to our reliability levels here, as I mentioned here on the slide. We didn't invent the scheme of the 195 possibilities to report any weather and impacts or severe weather. We recognized and we accepted an already existing European standard from the ESSL, from the European Weather Observer EVOP. This is actually a native app on the European level. And we accepted this, and we realized on the national level, we realized this already European-wide standardized API, and realized it on the national level in form of our web app wettermelden.at. So all the credits, please, to the ESSL, and we just recognized this already existing standard. So we are going now to another aspect of our scheme, the weather partners. So not only the subnational level and not only on the European level, we try to standardize the exchange of these weather reports and impact reports, but also with other partners. For instance, we provide some IT services. We provide hosting, we provide the API, we provide the technique of data transfer, and we also provide the training. And we are currently working on an online training portal for automated observer licensing, for instance. So a very good showcase is our collaboration with the spotter organization SKKM Austria. This is an association of very weather interested and weather enthusiastic people. So they are doing their business anyway. And with our method and with our concept, we do not want to intrude in any existing communities with our apps. So to say, well, hi weather community, now we are coming and you have to use our apps. With the API and the usage of the API, it is possible to keep existing communities and existing platforms homogeneous. So the only contact will be on the back side, not on the front side. So the only connection to our database is the API, and we are also receiving real-time weather and impact observations from this organization, and all the members of this organization are staying on their own platform, so they have their own traffic and it's continuous traffic on their own platform. So we, with our activity and with our collaboration, we are not disturbing any initially grown communities with any technical or organizational intrusion. So everyone is able to implement and to provide the possibility of weather reporting on their own homepage, on their own app, and this will only be connected to our database via the API. Another one is our weather partnership with schools. The most important point here is citizen science as a two-way communication. We focus on pupils older than 12 years, of course, because this would make much more sense to us. Our experience was that pupils, younger pupils, are not that concentrated and not that aware of weather as the older ones already. So our motto is more or less report the weather, avoid the hazards, and support our warnings with your reports. And of course, we provide services like webinars, workshops, and we are encouraging young people to look up. We had fatalities last year with a very fast-moving squall lines. There were 7 fatalities, and 2 of them were children and kids. So we are trying to go to the schools, and we are trying to train the kids and to make them aware that there are weather hazards which are coming very, very fast, especially in connections with thunderstorms. So we train them, and we are also providing climate knowledge, and we are also providing physics and knowledge about weather phenomena in general. Some case studies I want to show you. One case study, for instance, here from Vienna. There was a broken tree, as you can see, a very densely populated and very well organized area, the urban area of Vienna. So there is a very good response from, for instance, professional firefighter units, and they really there is a really fast response in comparison to rural areas. So there was a branch hanging in the air, and people obviously walking below this hanging branch and in deadly danger, so to say. So the firefighters came and solved the problem. So our observer just sent us also the picture of the firefighting response. And the picture of the reports on this day, there you can see the high concentration in the urban areas, in densely populated areas. Another aspect is the time lag of sensors, and also the time lag of activating emergency response units. What you can see is a 20 kilometer by 20 kilometer domain. From Austria. On the lower right, you can see a developing line of organized hail cells and thunderstorms. And what I want to show you is the real-time aspect of our observers and of our observation system. On the upper right, on the upper left corner, you see at the blue dot on the upper left corner, you see a weather station. There are 10-minute data available to us with a certain time lag of 2 to 5 minutes on the timestamp. These timestamps are UTC, and you see some wind gusts here. The wind gusts are on display. And already in the formation, inflow, outflow, in the formation of convective organized activity, the more western station here shows some inflow gusts and of course the outflow gusts of the passing thunderstorm line. And we received from a very small village at this timestamp a message: thunderstorms approaching without any impact. And the second message was from another small village. We have 15 minutes later, more or less, we have already impact intensity 2 with small branches broken and garden furniture tumbling. So this is the intensity class where you can report some wind gusts. And then you will have the measurement 1410. The 2 minutes should be also kept in mind by the forecaster. This is the latency, the time lag of the sensors. And then you will have the activation of the response units. The first one was called by telephone, and the federal agency activated a voluntary response unit at this timestamp, and followed by other local response units. And the last ones was, of course, due to the time lag of precipitation and catchment and flooding rivers, was at these timestamps. So you see there is more than 2 hours delay if you look at different sources of data and different sources of alternative data, like emergency response times and emergency response alarms. So there is a huge advantage in our system, as I see it as a forecaster, in gaining the ground truth in real time. So you can see even the lightning data information, a lightning network will have a small time lag of a few seconds. So we are playing in this kind of league of latency of 1 or 10 seconds maximum when you press the send button of our web app in order to report the weather. The last slide I will present you is the cross-border extreme events. That's the reason why we are engaged also at the European level. This was a case where I was on duty. So at the lower part, you see a hail swath coming from the southern parts of Germany into along the northern Alpine ridge into Austria. So I had access to the German system of weather reports. They are organizing this via a native app. And so around this area, I had this report of significant impact with 3 centimeters hail stones and a closed layer of hail. So I decided to have the second highest warning level issued to the public. And what you see here in yellow and orange with the small polygons are the verifications where hail was automatically detected by our remote sensing systems. And the yellow, these are communities, which you can see here. And the yellow communities had at least thunderstorms in form of lightning. And this is the on the lower right, you see the precipitation swath going through 3 countries with this moving supercell. So with this slide, I hope I did not leave anything out on important information for you. Thank you for your attention. Thank you for your time. And I'm very much looking forward to your feedback. Thank you very much.
Thank you so much for that, Thomas. A really great presentation, really great to see the architecture, but also your experience and that you have been on this for a very long time and learned not just from your experience, but also, I guess, the standardization from other parties in Europe. So I think it's a really great kind of cohesion of the different efforts to make this work. I think Valentina will help me field some of the questions. So we have a few questions on the chat, but while people are still taking in your very, very well delivered presentation, and people might be still thinking their questions, we'll encourage everyone to just put your questions in the chat, and we'll make sure to ask this for you, and we'll have a great discussion going on. So, Valentina, do you want to start with the first question that we have on the chat?
Yes, sure. The first question, Thomas, is from Tonj. I don't know your name. Sorry. Do you forecast different scenarios with different disaster risk? Have you done or collected some kind of prioritizations of material assets, hospital versus vacated building or important infrastructure? Wondering if scenarios and priorities like this will help support decision makers in times of uncertainty.
Yeah, this would be clearly not an impact-based warning, which we are issuing operationally since 2021. This would be a clear impact warning. We are working on this. We are working on identifying sensible regions, sensible infrastructure, and as a basis for estimation the risk and the impact. So this is still work in progress. Of course, we are going to do this in the near future, hopefully as soon as possible. But still, these systems and these mechanisms are not yet in operation. Thank you very much for the question.
Thanks, Thomas. And it's good to know that there's some work going on, and clearly there's still lots of things to explore in this field. And yeah, we have a question from Lee, and she thanks you for your very much for the interesting talk. Her question is: will the ground truth observation be fed into model verification or assimilation afterwards?
Yeah, I mentioned this point. Especially in our activity on HIWeather network, we also involved the European Center of Medium Range Weather Forecast, and a task from this side was reliable. Can you provide reliable information? We have this special way in Austria of training the observers, because we are a small country and we have a rather small community of highly motivated people. So historically it was easier to train them to have reliable information and to have reference reports, so to say, in comparison to all not educated reports. But if you take the example of Germany or France, they have to apply a lot of checks there, automated checks. But if I apply automated checks through nowcasting systems like weather radar or satellite data, I'm excluding uncertainties with those measurements already, because I really want to have the ground truth. The ground truth many times differs from our sensors. So if I'm applying some checks which I'm running by sensor data, so I dismiss probably valuable data from the ground truth. So to me, it makes more sense. And to me, historically, it is more easier to educate the observers than to apply such checks, quality checks, sensitivity checks, and the like. So I hope this was the answer to the question.
Thank you, Thomas. The next question is from Sally Potter. She asked, can you please talk about how you determine the potential impact for an impact-based warning, for example, with a risk matrix or risk model?
We do not communicate the risk matrix, which is well known, for instance, from the UK Met Office, but we do it internally. So we have a clear standard of this risk matrix. We are relying on a simple color scheme for the public, but internally we use the common risk matrix, of course.
Thank you for that, Thomas. And I guess just a follow-up to Leah's question from Sally as well. It's like, have you ever changed your the level of expected impact in a forecast due to crowdsource of observations in real time?
Yes, especially since I'm responsible for this program and for this project, I very much trust all the people which I basically trained myself. Most of them, it's more than 150 people during the last 10 years, especially. And when I receive, for instance, during a wintertime event, I receive a report about icing on the ground. I very much trust this report, especially if it comes from a trusted spotter. And I had this winter, from 22 to 23, I had 2 cases where I was on duty when I had reports in cases of, undecided cases. So I was not sure whether to disseminate a warning, to issue a warning for this area. But with the reports, especially during the night, where you cannot rely also on webcams and such sources, the report comes in. I didn't waste any time, and I just issued the report, and successfully so. So I have very nice case studies and showcases where I really can show again that these reports in real time and reliable reports in real time will change your activity during a warning situation significantly.
The next question is from Faye. Fantastic talk, thank you. What is the level of engagement with your citizens? How many general members of the public versus trained observers?
This is a very, very interesting question. We have, I have prepared the numbers, but since the time is limited, as I told you, during the last 10 years, we trained about 150 trusted spotters, which is the most advanced level of training. You have active members of associations like the Sky1 Association or the Ham Radio Association. There are about 100 or 200 members, active members of this association with the reliability level of 1. Currently, because of our training activity, most reports come from trained observers, and we are very cautious to go public and to have a lot of false reports. So the minority comes from the public. In a further stage of this program, probably the public reports will be the majority, untrained public reports. Then there is the first level of training. There will be about 30%, for instance, and there will be 5% trusted spotters as reference observations. So we have these light tower observations where we can compare all other observations from the area. That's the aim. So we are working, but still now the most common report comes from an educated reporter. Actually, that's interesting.
Thanks, Thomas. And I think one of the great interests from the audience is about this 3 levels of observation training available to your citizen scientists. So a question from Helen Roberts is, were those developed in-house or is it online learning? Maybe talk a little bit more about this 3 level of training that you provide.
The concept was invented by the ESSL, as I told you, but on a national level, we expanded this concept, and the development and implementation of the Trusted Spotter Network concept was in-house, clearly. We just applied the idea of different quality levels, but we did our work in-house in order to organize the network, to organize the partners, and to organize the three level training program. Work in progress is already the aspect of online training, which makes the training more simple and more feasible for us, because it's very hard to engage personally in a personal individual training with trusted spotters. So there are only a few of them. But we are hoping for a big effect for the online training. With this online training, we will probably rely to a HIWeather call system of microlearning, and we are currently developing in connection to our school program. We are developing question and learning techniques, also with the response and the feedback of our school partners. So this is. All of this is going to be connected, and all of this is a kind of win-win situation for every partner, because they are also involved in the scientific aspect of weather education, of course.
Thank you, Thomas. The next question is from Kazumi, and it says, "Thank you for the presentation. How do you cope with data latency issues when it comes to crowdsourcing? What are the major challenges that your organization faces when conducting a crowdsourced weather project?"
As I said, the latency of sensors and the latency, the time lag isn't existing. We are very proud to say that our system, our technical system, our programming system, our API, we use message queuing, which is very simple and very fast. These techniques and these methods enable us to have instantaneous and real-time ground truth via our observers. So this is a very valuable asset, especially in comparison to latency of sensors and latency and time lags of other alternative data sources, which I showed you could be probably 1 or 2 hours even.
Yep. Thank you. You mentioned that you have the web-based app for contribution for the, but do you also have an app, or is this all web-based?
There was a lot of discussion within our institute when we started to implement, and I was very happy to have Rainer Kaltenberger as partner and as co-author of this concept. So we had hard discussions with our management. They wanted to implement native apps, which is a common instrument and a common tool for weather observations for national weather services, especially here in Europe. And we thought about the thresholds, and when you have to first download this native app on your mobile device, and then you have to install this native app on your device, and then you have to register, and then you have to then you can start. So we were really convinced also by the aspect of financial support and of cost ratio. So a native app at the beginning might be very cheap, but the maintenance of the native app is really expensive on the long run. So we decided for a little more expensive version of a web app, meaning initially also already a progressive app form, which is a special term for functionality of a web app. The architecture below the graphic user interface is the same. So you have Java below. 90% of the program is Java. This is identical to a native app, but it's just a difference of the graphic user interface, which makes about 10% of the program, but is working very successfully with our example. We could, if wanted from a partner, we could easily provide and very fast provide also a native app, but it's the cost aspects which is hindering us by doing so just initially. So we heavily rely on the web app, which is functioning just like the same.
Thanks, Thomas. And next questions. Do you capture systematic information and reports of response actions in addition to impacts and meteorological observations, both from organizations and agencies and also from individuals?
Well, we are by law we are not able to publish our data which we receive from the federal response agencies. We receive information about the activation of response units. And as I showed you the case in the study, that these activation timestamps are delayed in comparison to the real-time ground truth information by our observers. So yes, the answer is yes, we utilize different sources of information, but we are legally bound in order to what we can use, what we can utilize, and what we can include in our disseminations, in our warnings, in our programs. So there are different levels of data usage, availability, which we have to cope with. I hope this was the answer to the question.
Thank you, Thomas. I'm going to combine a few of the questions. So one is that, are there any specific tips for NMHS in other countries who wish to develop what you have in Austria? And what kind of investment and resourcing does it require to run something like that? And perhaps is there knowledge base of best practices as well? So maybe a bit of comment on that. Tips for other countries.
We are in the lucky position of the historic development. So it started, historically, it started with emails coming from SKY1 organizations. The emails had been printed out and lying on the printer for 1 hour. So this was the beginning. And then we started to collaborate officially with SKY1, for instance. And then it was clear that SKY1, every SKY1 member, every enthusiast sent us an email, but with different aspects. So one was sending precipitation amounts, total precipitation amounts, or precipitation rates. So this was different. And we really saw immediately, we saw the need for standardization. So that was the step to form the Trusted Spotter Network in order to standardize these reports. And as I told you already, existing, this was around 2006, and from 2002, the ESWD already existed. So we tried to standardize our Trusted Spotter Network and our observers and our observations in training the observers for the ESWD, which has very strict criteria, and a lot of uncertainties among the observers have been the result of this training. So it was obvious for our partners, the ESSL, to implement the EWOP, the European Weather Observer, with much more possibilities to report. So 195 is a lot. And this is, in principle, this is the textbook for the climate observer, for the professional climate observer, translated into public intuitivity. So we have these 195 parameters, but still we are not worried about the usability of our program because we are explaining them instantly in our app via the subtitles. So you can match the impact. Is it fitting? And then I report it. Is it not fitting? I try another parameter. So our tip is, this is a very difficult question. Probably you have to stick to your financial resources. You have to pick up an aspect which is most important to you, either the training. The training will be very resource intensive, or you automatize by developing or using an existing online training. Hopefully we're fast and we can provide this form of online training. It's no problem technically to provide our online training to other national weather services. We can also provide hosting and so on, but this will need also resources from either side. So I don't want to make a business case here, but if you don't want to develop from scratch, or so, we are happy to provide hosting and services as well. But still, you have to decide in your institute. You have to decide which aspect of the crowdsourcing, or because crowdsourcing is not equal to citizen science. Citizen science is always two-way communication. Crowdsourcing is just one way. So you have to decide which aspect of these activities is the most important to you.
Thank you very much, Thomas. And that really it's a very interesting webinar. Lots of questions. We apologize that we were not able to ask all of the questions that people asked, but just goes to show that this has been a very interesting topic, and people kind of really enjoyed your presentation and the Q&A. So thank you everyone for attending. Thank you, Thomas, for your time and your sharing your experience. Yeah. Go
Just
ahead,
one. I'm of course you have my email address. Of course, I'm open to any questions. Please send it to me via email. I try to answer as soon as possible. Thank you very much for your feedback.
Thank you for that, and thanks everyone for attending and for your active participation. And we want to take this time to conclude this session, but to thank everyone for coming today.
Thank you very much.